Hi, I'm Scott Moore with Moore Engineering. I'm a civil engineer concentrating in forensics, and I'm going to talk to you today about moisture testing, concrete moisture testing. And if you're interested, you can look at our blog on our website, which talks a little bit more about this topic. Specifically, there's an article called Concrete Moisture Testing, What is it good for? Absolutely nothing. And you'll learn a little bit about the difficulties, but also the value of the testing. Today I'm going to talk about a matrix that we've developed to try and simplify the principles contained within both that article and the industry standards talking about concrete moisture testing. So, moisture testing, what is it? Concrete moisture testing is the measurement of the relative humidity of air within a concrete slab. And the purpose of this testing is to determine the acceptability of a concrete slab for receiving a floor covering. A floor covering is a floor. So before you install an adhesive adhered floor to a concrete substrate, you need to make sure that there's the appropriate levels of moisture so that the floor doesn't fail after installation. So there's a couple of basic principles about this, and we're going to talk a little bit about that in this video. The idea with this is understanding when you need concrete moisture testing, what does it do and what does it tell you to do? And I'm going to give you some really precise guidance in that. The matrix itself is relative to primarily ASTM F2170 or ASTM F1869. ASTM F2170 is testing the relative humidity of air within a concrete slab using a relative humidity sensor or a hygrometer sensor. The calcium chloride test, ASTM F1869, is the measurement of moisture emitting from the surface of the slab. And as we do those tests, we find that we can either pass those tests or fail those tests. I'm going to talk about the F2170, the relative humidity test. It's the most common and easiest, essentially, to do now. And usually, the requirement for passing that test is 75% relative humidity in the air in the slab. It does depend, however, on the adhesive manufacturer's instructions, which is really important. Review those specifications for installation timing, and all the things you have to do prior to installation. The preparation usually requires ASTM F710. It references that for all the things you have to do, but also understanding what's that relative humidity or maximum requirement. And if you pass the test, you have to ask a couple questions in order to get to your answer. The first question is there a vapor retarding system installed? Now that vapor retarding system, they're typically installed underneath of the concrete slab prior to placement of the slab. In older buildings, there often is not a vapor barrier installed, so it's important to determine that. And the way we do that is we drill a depth hole. So we drill about a 1/2-inch diameter hole entirely through the concrete, and then we use usually a piece of weld wire to measure the depth of the slab and also to probe underneath the slab and determine if there is a vapor retarding system installed. That vapor retarding system is usually a plastic membrane that is flexible and easily detectable using that wire. If there is not a vapor retarder installed, the information is still valuable to consider the level of moisture in the slab at that time. If there's no vapor retarder installed under the slab, you can't be guaranteed that the relative humidity in the slab is going to remain constant after a floor is installed. And so we always recommend the installation of a vapor retarding system on top of the slab prior to installing your floor covering. If there is a vapor barrier installed under the slab, and the results are below the manufacturer's specified values, which that industry standard we mentioned was 75% for relative humidity and 3 pounds per 1,000 square feet per 24 hours for ASTM F1869. If the answer is yes, you're within that, then you can go ahead and install the flooring. And what that's telling you is after installation of the flooring, the equilibrium of the concrete slab relative humidity will be whatever your tested value is. And that's the research based on the depth of the slab. The research has indicated that at that specific depth, that is representative of what will be the equilibrium. Now, if the results aren't within the manufactured specifies, you have two options. The first option is you can dry out the slab, which takes time and requires additional testing to reassure that you have dropped the moisture within the allowable levels. This takes time and effort and sometimes can require grinding of the surface of the slab and installation of additional relative humidity mitigating air conditioning or similar dehumidifying equipment. The other option is you can use either use an adhesive with a higher moisture resistance, so instead of 75%, maybe it resists up to 85%, and if that's what your numbers are, then you're good. Or you can also use a vapor retarding system installed on the surface of the slab, which of course is the most expensive option. So a lot of our projects, the project is trying to move forward. We're at the point in the schedule where flooring is going to be installed, and of course, what do we need to do? We need to accelerate this process. We don't have time to wait to dry out the slab. And so the compromise of using an adhesive that is compatible with the humidity in the slab usually works pretty well. So if you have any questions about this video or the content, feel free to leave a comment, or you can contact us on our website and ask any questions. And if you have any ideas for other things you'd like to hear us talk about, feel free to make those suggestions as well. Thank you.